So you get a phone call from Tim. Oh,
right. I got a message on the mobile phone from Tim saying he'd found something up at the swap meet at Toowoomba, and was I interested, and a couple of pickies. And as soon as I saw the pickies, I knew exactly what it was. Now, he'd been alerted by seeing this, the Naval Wireless Works at Randwick, and our previous discussions that had been the infamous Father Shaw's factory that had been bought by the Commonwealth Government in 1916 and turned to making radio equipment for the RAN and for the AIF and for the Indian and New Zealand armies and navies as well. So I knew straight off exactly what it was. The next question was how much the dealer who had it, or the vendor at the swap meet who had it, wanted for it, and could it be affordable? And the thing was, he really didn't know what it was. He knew it was a generator, but he didn't know what it was. Seeing Randwick, he knew it was Australian. He was a professional dealer, so he was interested in getting top dollar for it. He was very non-negotiable on price, but I think that he thought that it was World War II.
right.
There were similar generators used in World War II that they do look similar. They served exactly the same function.
And they had the Douglas engine on it?
They had Douglas engines as well, but this is an L-head engine, which is classically 1910s. The head actually is a solid cast cylinder and head as one piece. The chamber extends across, and these two plugs come out to access and replace the valves. And the valve operation is exposed inside here in the engine.
You can see it on that side there.
So when you turn around, you can see the valves operating. Now, L-head finished in the early 1920s, and you go to detachable heads with sealing gaskets, and you physically remove the head of the engine off the cylinder to access the valves, and that was a far better valve system, and it's the valve system still in use today on all petrol engines. And the World War II Douglas engines, of course, were that overhead valve detachable head engine. So
this one was manufactured in 1916, because you found the date on it?
That's correct. So it's its first year of production.
So that was the first year of production, was it?
Well, the factory was only bought by the government in 1916.
Oh, I see. Okay.
So it's the first year of production. It's entirely made to the British service pattern.
Mm-hmm.
The British government had been making these since 1913, or the Marconi company had been making them for the Royal Army since 1913. The Australian Army had purchased several sets in 1913, and they were delivered early in 1914, and the first military radio operation in Australia was with the Marconi 500 watt pack set, and it gave a nominal 30 mile range or 35 mile range, but at night time with good atmospheric conditions, actual ranges of 600, 700 miles, 1,000 odd kilometres are recorded.
You've mentioned the pack set, and in photographs that you've sent me, the pack set actually splits the generator across a saddle mounting, doesn't it?
Well, that's right. The Army wanted this particular unit to be a mobile unit to be used with the cavalry division.
Right.
So it needed to be able to be transported by horse transport, and it was based on the experience in the Boer War that when cavalry troops made wide encircling movements, that High Command lost contact with cavalry brigades and cavalry divisions. So the idea was that you had mobility, the generator and the motor were either side of the saddle, a drive shaft between the two. When they're on the horse, you just pull the drive shaft out, throw the whole lot on top of the horse. And it was actually 4 pack loads on the horse. 1 pack load with the 2 big boxes, which were the wireless station. 1 pack load with 2 suitcases that held all the cables, the guys, the antenna and the earth mat. And then a 4th load carrying the poles for the masts for the antenna, 2 10-metre masts with a total of 16 segments.
And that drove a Marconi?
Marconi 500 watt transmitter. It's a spark transmitter, and this unit here is your spark generator for the transmitter.
Well, we'll get onto that in a minute. Let's just keep looking at the engine for 1 second. The thing about this particular unit that you've found is the fact that it's so complete. Even down to, you were showing me before, the strainers in the fuel tanks are still there, which I find is rather amazing, but there they are.
There is the strainer out of the fuel tank.
So this particular unit is sort of like someone who has collected this or hung on to this and appreciated what it is and not stripped it for motorbike parts.
Well,
because a Douglas engine, as you were saying, this is a Douglas stationary engine.
First of all, as a generator, you could use this as a generator to power your lights in your farmhouse or anywhere that's off the main electrical grid. But the spark generator is a piece of junk for that. So why somebody who's using it for a generator just wouldn't throw the spark gap generator away, I don't know. But your other problem is this is essentially the same engine, the 2 3/4 horsepower 2-cylinder horizontally opposed engine used on the Douglas motorbikes from about 1913 to about 1923. They're very, very collectible motorbikes. The engine's a little bit different. As a stationary engine, the chamber for the crankcase oil is a slightly different design. The engine mountings are slightly different to the motorbike mountings, but pretty much, and the fuel tanks of course are quite different, but pretty much everything else is straight out motorbike parts. And
as such, not a lot of them survived.
Well, the thing is, they turn up at a swap meet, they turn up somewhere, and somebody who's a motorbike person says, oh, they're the parts to get my motorbike running again. So getting one that's not been stripped down to power a motorbike and keep a vintage motorbike running is really quite extraordinary.
And that leads to the fact that with the research you've done at this stage, you and a few of us who have constantly looked haven't found an example as complete as this one.
First of all, of the engine setup with the data plates to the RAN, there are 2 other known examples, and both have been partially stripped down to support motorbikes, and both are owned by motorbike collectors.
Right.
So they aren't running, and for practical purposes they will never run again. Internationally, there's at least one of these known as the stationary engine that is running, but it's a British Army one, not one that went through the RAN workshop. Of the motorbikes, there are plenty of the motorbikes running. There are also quite a few of the motorbike engines that have been taken off the motorbikes that people are just running it virtually as a stationary engine, but are actually the motorbike engine. There are minor design features that are different to the motorbike engine. The flywheel here has vanes on the back of the flywheel just to improve airflow over the engine. Now, as a motorbike engine, the flywheel has the same disc shape on the side here on both sides.
Okay.
As a motorbike, riding along on a motorbike, you've got plenty of air circulation around the engine. This is entirely unnecessary.
So just quickly, let's go back to the front of the engine and let's have a look at the carburettor setup, because that's quite unusual. Well, I think it's quite unusual.
Well, first of all, you've got your float chamber here, and this is very typical of a float chamber arrangement used on small engines such as lawnmowers and the like through into the 1960s.
A bit like a Villiers carburettor as such.
Oh, very much. So,
British Villiers. And there's your float.
there's your float and the butterfly wings, so that you can push the float down to just give it a bit of priming,
Yeah, okay.
when you're starting the engine.
Very much like a Victor's Villiers. But this section of it isn't.
Well, first of all, typically World War One, there is no air filter.
Okay.
You're drawing straight raw air into your carburettor with all the rubbish and crap that brings in. This is very typically First World War, and something that we wouldn't dream of doing today, of having a carburettor and not, or any engine, and not using an air filter first. But, sorry, this arrangement here is strange and I don't understand. First of all, we've got a choke port straight to atmosphere here on this control to dramatically increase the amount of raw air coming into the carburettor, and we have another control on this side here to change airflow through the carburettor, and
some sort of balancing of the two, or balancing the two cylinders, or the amount of air the two cylinders get, or?
I think it's for the manipulation of the air-fuel mixture for ignition and for the initial cold running of the engine till it warms up. That's my interpretation of it. I've just never seen one arranged like this. I don't know why you would arrange it like this, because it actually doesn't make sense to me. It's beautifully made, but frankly it's a pain in the neck. And I'm just so used to later technologies that are so much superior. Why you would do it like that? I mean, this is one of the things about First War vintage technologies, is so many things, you look at them and you think, that design is shocking. It's 4 times heavier than it needs to be, and it's cost 10 times as much to make as it should have cost. Why on earth would you make it that way?
Over-engineered and such. And at this point of time, we discussed this before, but at this point of time we don't actually know what that little pump's for there.
Well, it's priming, it's
oil, possibly to the main
it's
bearing.
oil, and it appears to be to the main bearing. It's just a little leather plunger pump.
Is there any pressure applied to this tank at all? Is it
I don't know.
Is it a direct pressure oil feed of some
I
description?
simply don't know. I would expect that there's a geared drive off the main
Oh,
crankshaft
possibly in here
to
somewhere.
provide pressurisation for the oil when the engine's running. That was quite normal at this period.
Well, there must be
But
somebody out there who'd know, I'd say.
I simply don't know. You've got a sight glass here to confirm your oil flow. You've got a sight glass there so that you can check the oil level in the sump. And this is a breather vent on the oil filler port. And it's been made with copper gauze screen fitted in so that debris can't contaminate the oil. But it's like so much of the engine generally. You look at that and sort of, why would you make it like that? I could make that for 1/100th of the cost by simply just having a cap, having a piece of pressed gauze in the cap and a hole in the top of the cap.
But in those days. And what's this meter for?
That's a tachometer driven off the magneto, and that's for adjusting the engine to correct speed for the generator.
Okay.
So you've got a telltale for the setting,
Yeah.
and when it's running, another needle will come up, and the idea is you adjust the throttle till you come to the desired speed. This is the throttle control here. It's a standard Bowden cable arrangement. So you would, again, I don't have the starting instructions. I would presume that you start it at a lower speed, and once the engine warms up, you progressively increase speed and you lock in to the desired speed. And if the desired speed's not the, if the actual speed is not the desired speed, the Bowden cable can be adjusted here. So it's very much like a brake on a push bike. It's the same technology. The magneto is located just in here between the fuel tanks above the engine.
Just before we go that way, do you reckon that's the original muffler on it? Seeing it sticking out the side of the case like that, or the base plate like that, or?
I have no idea. I've got one good photo of this engine being used in German East Africa in 1917. It is a Marconi made engine, but it's essentially identical. Unfortunately, it's photographed from this side, and I can't see the muffler in the photo.
Well, just presumably, would this have had a cover over it originally?
No, it would have never had a cover over it. It would have been used for both army and naval use, and I would expect that these holes here allowed it to be bolted down to a deck for naval use.
Okay. All right, let's just move up to the other end and we'll have a look at that.
Well, first of all, lovely nameplate to the Royal Australian Naval Wireless and Electrical Workshops in Randwick, which was the infamous Father Shaw. Now,
let me come around this way.
This is the spark generator here. So the generator is taking off to the lower box of the wireless here with the low voltage connection at 170 volts, and a transformer inside the lower box of the wireless is generating our high voltage, which is coming back to one of these horns, and we're creating our spark here with the other horn feeding the high voltage back to the wire. things. This has got an adjustment here, and this whole assembly can be rotated backwards or forwards
to achieve,
relative to the generator.
and it's got a scale. Let me just get a look at that. There's a scale on the back of it in there with a pointer here. So obviously that adjustment will rotate the whole casing as such to attune the passing of these studs against the, let's call them the receptor studs on this side. And that's a dielectric in there, or an insulator in there.
Yes.
So it's a really amazing piece of gear.
It would be interesting, well, because this part of the unit and the base plate are all made in Randwick, it would actually be interesting to determine what material's been used for that and for these.
Oh, okay.
In the UK, these would have been ebonite, which is a very hard vulcanised rubber.
Mm-hmm.
The rubber is actually baked till it's almost a rigid plastic.
Right.
And that was the standard insulator used on all wireless equipment of the period. And when you pick up a first war vintage wireless station, you'll have this black sheet on the top and everything's bolted to that, and that will be ebonite. We had difficulties getting supplies of ebonite in Australia during World War I, and some other equipment I've got built by the Randwick Radio Works, instead of using ebonite, they've actually used mineral slate.
So that leaves the $99 million question. We know that Bruce has diagnosed it as having no spark from the magneto, and so what are your plans from here for it?
I want to restore it to a running order, and I want to restore it and conserve it to a museum quality grade. Now, I'm amazed at the general condition it's in.
It's just an amazing condition for its age,
yeah.
and the completeness of it. Well, that's
I'd like
excellent.
to have the engine running. It doesn't look like much work is required to get it running. I'm very surprised that the leads are still here. I've not investigated the leads to see whether the high tension leads can still pass current or not.
Mm-hmm.
I'd almost be surprised if they can. Then the magneto, a variety of magneto faults develop in old magnetos, and there's several vintage car places around Australia that can actually restore and rewind magnetos.
Well, Ross, I think it's a magnificent bit of gear, and I'm glad it's fallen into your hands so it'll be preserved, and I wish you every success with it.